We will solve step by step for real numbers x and y such that x plus y equals 4 and x cubed plus y cubed equals 28. Step 1. Write down the system we want to solve. Our two equations are x plus y equals 4 and x cubed plus y cubed equals 28. Step 2. Use the identity for the sum of cubes. X cubed plus y cubed equals the quantity x plus y cubed minus 3xy times the quantity x plus y. Since x plus y equals 4, substitute that into the identity. We get x cubed plus y cubed equals 4 cubed minus 3xy times 4. That simplifies to x cubed plus y cubed equals 64 minus 12xy. But we also know that x cubed plus y cubed equals 28. So set 64 minus 12x, y equal to 28. Step 3. Solve for the product x, y. Move 28 to the left side to get 64 minus 28 equals 12xy. So 36 equals 12xy, which gives xy equals 3. Step 4. Use the fact that x and y are roots of a monic quadratic with sum and product. The general form is t squared minus the sum times t plus the product equals 0. Substituting the values, we get t squared minus 4t plus 3 equals 0. Step 5. Factor the quadratic by inspection. Without using the quadratic formula, we need two numbers that multiply to 3 and add to 4. Those are 1 and 3. So the factorization is t minus 1 times t minus 3, which gives the roots t equals 1 or t equals 3. Step 6. Since x and y are the two roots, the ordered pairs are 1, 3 or 3, 1. We can quickly check both conditions. Each pair adds to 4, and the cubes sum to 28. Both checks succeed. Final simple and real solutions. The ordered pairs are 1, 3 or 3, 1.